Begin with this warm-up. Pause the video now.
Stories we have that we tell ourselves, stories that bend with time. Histories change like books on a shelf, pages that need a read.
The point of this lesson is to look at graphs, because graphs do really tell you a story of what's going on. Or it works in reverse, where the story can dictate what your graph is going to look like. So we're going to dive into a bunch of scenarios and analyze the graphs themselves. Example 1 says that Amy leaves home and walks to her friend's house. Then she spends an hour at her friend's house chatting. Amy realizes she's late, so she runs home. We're going to draw a graph below that's going to show Amy's trip. Every graph is going to have an x and y axis. You already recalled that your y-axis is this one, and this is your x-axis. And this is where we need to go back to dependent and independent variables. Well, it's nice that Amy leaves home and walks to her friend's house, but that tells us that that takes time. Time is going to be the independent variable, or the label on the x-axis. Well, Amy's leaving home and walking to her friend's house, and so the y-axis is going to be her distance from home. So let's draw a picture of this graph story. Amy starts at home, and she walks to her friend's house. She spends an hour at her friend's house, so time is passing, but her distance from home is not changing. Amy then realizes she's late, so she runs home. That's what her graph story looks like. The y-axis shows her distance from home. The x-axis shows time passing. The question then is, why is the section showing Amy's trip home steeper than the walk to her friend's house? This is steeper because she's running. So her distance to home is rapidly decreasing. So we'll just say it's steeper because she's running. Here she was walking. So her change in distance over time was not as fast. And then finally it's flat when she was at her friend's house because she stopped. She wasn't changing her position, but time was still moving on. Here's another graph story. It says Joyce is driving to her aunt's house. She gets in the car and adjusts the seats and the mirrors. She pulls out of her driveway and drives through town. Then she gets on the highway and drives for a while. She gets off the highway and pulls into her aunt's driveway. We need to create a graph of this situation. I'll make the axes x and y. This time, we're still looking at time as our independent variable. The y-axis is going to be her speed this time, because everything in the problem was talking about her speed. I'd like you to try to graph this graph story. So pause the video, reread the problem, and have your pencil moving on the graph while you're reading it. This is how I drew my graph story. Does yours look similar? This one was definitely tougher than the first one. The first thing to notice is that she is in the car and adjusting her seats and mirrors. Well, that's this part here. Time is passing, but she's not moving. I'll just write seats and mirrors. And then it says she pulls out of her driveway. That would be her speed pulling out of driveway. Then she reaches town, and I would assume in town that she's pretty much going the same speed, a slow little speed there. So it's kind of a constant, maybe 25 miles an hour. I'm making that up. Then what happens? Then she's getting on the freeway or the highway, so she's really going to have to speed up to reach that high speed. This is her on the highway for a while. It says she drives for a while. So she's cruising. Then when you get off the off-ramp, you're going to have to slow down quite quickly. So you're going from like maybe 80 back down to maybe 40. And then she's probably driving through town a little bit. And then this is her slowing down into her aunt's driveway. And then finally she'll be stopped in the aunt's driveway. So the question asked is, why is the second part of the graph higher than the first part? And I'm assuming it means these parts right here. And again, this part is higher because she's going at a higher speed. Remember, this is speed right here. So we could even visualize this as maybe 80, or maybe I should say 70, but I like the speed. And maybe that's 25. The question then asks, why doesn't the graph cross the y-axis at the origin? Well, because you're starting at 0 time. So it's not crossing the y-axis because you can't go negative time. But it starts right at the origin. How about you do this example and answer all the questions before you come back. This one says an airplane takes off from an airport and reaches its cruising height where it stays for 2 hours. And then the airplane lands. Well, we're supposed to use the graph to describe the airplane's flight. And I can tell you now from looking at it, I'll help you out with these, time is still our independent variable. But the thing that's changing and that it's talking about is the height of the airplane. That's called altitude. So your y-axis is the altitude of the airplane. You go ahead and fill everything else in. Fill in the graph and then fill in each of the questions. Pause the video and come back. Here's what your graph story might have looked like. Things can be a little bit different because this is really just a sketch. You might have had a steeper slope here, and that's okay because airplanes really, they get high pretty fast. You might have had a little less steep descent here as the plane was landing because it really doesn't slam on the brakes and drop along. You know, it takes a while to drop. So maybe I did that a little too harshly. My slope should have been a little lower. The question was at the end, is the slope of takeoff right here, is it positive or negative? And that is positive, and you wanted to say something like this, that as time increases, your altitude increases, and that's also indicating a positive relationship. So I have a few more examples, and I'm just going to let you go through them because the more you do these, the more obvious they become. So this is going to be like guided practice for the rest of this lesson. So I'm going to have you just pause the video and read this and do this problem, and then unpause it and I'll have the answer for you to check your work. Pause the video now. Here's that picture. Michael is a baby who is born, and he begins losing weight immediately after he's born, which is quite common, so don't worry about Michael. And then he starts to slowly gain weight, and then he gets really hungry, and he's gaining a lot of weight then quickly. Let's try a couple more. Read this example and answer the questions based upon these 3 graphs drawn below. Pause the video now. Here are those written out answers. So take a minute and read those over. But your answer for which of the graphs follow the story, it's this last one here. Pause the video if you need to check your answers. I'm going to move on to the last graph story. And it says Annie the cat is taking a nap on a couch, and she sprints to the other side of the room to attack a fly. She then sits watching the fly for 5 minutes, and then Annie walks back to the couch. Go ahead, draw out this story, and then answer the 2 questions. Pause the video now. And here are the answers to that graph story. Thanks for watching, and remember, these always get easier the more you do.